relationships and the different slopes and everything else in the graph, did we get to these problems of asking, is it proportional or not?
No.
Yeah, that's what I thought. So, really quickly, go ahead and put these tables in your notes. If you want to, for the first table, you could just write like sugar and lemonade. You don't have to write the whole names that they have there. You could just write sugar and lemonade.
When I didn't see what we had to put in our handbook, I was writing.
You're fine.
The,
So plan book is KA due tomorrow and next Tuesday. So it's just weird right now because we're doing Tuesday due dates.
When's the next time we come back to school?
Depends if you're mastered or not. If you're not mastered, you'll be back here later this week with us. If you are mastered, next Monday will be your next school day.
You'll be here on Wednesday.
Who what?
You'll be here on Wednesday.
Yeah, if you're not mastered, you will be here on Wednesday. So Nate, make sure that you're getting this table copied down.
Yeah, it's going.
Ah, so we can call our notes, by the way, if you want a header, checking proportion. And really checking proportional, question mark. I don't like when I make like partial sentences, but yeah, that's what we're doing is we're checking if things are proportional. So the first table we're going to talk about, I'm going to go ahead and cover up the other table, is sugar and then lemonade. Actually, I need to move my table a little further down. So I'm going to skip some paper and say sugar and lemonade. Try to leave some space around your table. So a third, and guys, when we're writing numbers down, we should be analyzing if there's any relationships that we see, if there's anything interesting, if there's anything like really weird going on. Anyone tell me any observations that you see? Sorry, now that we're in the classroom, I gotta get used to you guys not having a screen right in front of you to see this. If you need to see this bigger, tell me. Or here's this bigger. It's 1/3, 1, and 3 on top. On the bottom, it's 1, 3, and 9.
They're all times 3.
Ooh, they're all times 3. Very good, Natalie. So, do you mean times 3 this way? Or do you mean times 3 this way? It's all times 3.
Yeah.
Now, here's the weird thing, though. Those are two different multiplications. So this, I'm going to turn this into not red. This red arrow across the middle of the table, please draw this on your notes. That times 3 is the constant of proportionality. And I think we're at the point where we can start abbreviating. So that times 3 across the table, going from sugar to lemonade, that is your constant of proportionality. The times 3 on the outside is a totally different times 3, but for a proportional relationship to be proportional. So let's make a little note. To check proportional. To check proportional, we have to check two things. Sorry, I can pull my camera this way. Anyone tell me what we have to check proportional? And if you've done your Khan Academy already, you've probably seen this. The first thing that we've been used to is we have to have the same constant of proportionality throughout. So the number 1 that we can write here is check CP, which is how we get from X to Y, right? So when we check the CP, that's going from x to y, are these all the same? So we have to check all of them. And guys, if you can't read something I write or whatever, like I got to get used to teaching here again. I may start taking notes up at the board again. Kind of have to decide what's going to work best. The other thing we check is what we wrote in purple. And this is kind of weird to talk about. So guys, I want you to draw this picture. We went from little x to a bigger X. So what we're going to draw is a little x and a bigger X. And then we're going to draw a little y to a bigger y. Mine does not look super pretty.
I'm not going to see closer, I can.
Yeah, absolutely. Take this one up front, or if you want me to keep a close eye on you, take this one right in front of me, or yeah. I did not move the seating chart yet, so just cross your name off where you wrote it on the tape and write it wherever you decide to sit. If there's no tape, I'll come put some on there. So this is outside the table. The constant of proportionality is inside the table. So guys, the easy thing you can tell yourself is you check the multiplication inside, and then you check the multiplication outside. Thank you for catching me on that. So we check the multiplication inside, we check the multiplication outside. So I want you to take a moment to look at this table and check those things on this table. Let's go ahead and write this down so we've got it in our notes to reference back to. So you can do hours and earnings. I know you can't see everything I'm writing, but we're just copying that table. Guys, it was in 8th grade that I found out that I needed glasses. So please, like Nate just did, if you decide you want to move closer, you can. And if we decide we want to put desks here, that's totally fine.
Okay.
So that's what I've been deciding is, should we pull desks forward? Do I need to get a couple more desks? Like if you want to bump up, we can just move this desk like physically. Shoot, we could just move your desk. But we got told we're not supposed to scooch stuff on the floors too much. So that cabinet did that to the floor.
Ooh. What?
See the giant scratch?
Right.
Yeah, I know. I was like, I didn't do it. It wasn't me. But that's it. That's what happened.
At my house, if you drag something across the floor like that, my mom gets super mad at you.
Yeah, because it'll mess up your floors. So yeah, feel free to move.
My brother drags like laundry baskets.
And actually, this desk can also be used. I don't want it to be like a fight over who gets the wheelie desk, but this was an extra desk another teacher had, so if somebody else wants to move up closer, we can move here and then be able to easily move things out. Guys, one of the things I'm most excited about is now that we're back in person, we can like play giant Jenga again, or play trash get ball, or like I have a classroom that is taller than I've ever had, and I got windows and doors and like, I can shut that, but it's so quiet down here on this end of the hallway.
Yeah.
I don't even,
Should I
yeah, no one's down here.
tape right under Miriam's name, or is
I'll
that-
put some more tape there. Give me just a second. Hey, so copy this table down. If you don't have it copied down, please do it. 1, 2, 3. I actually thought about bringing my coffee table back in. I don't know if you guys ever saw that, but I used to have a little coffee table in my classroom that a student could sit at if they wanted to like sit on the floor, like on a pillow. Problem is I can't really have pillows in here right now. A dollar symbol is supposed to have 2 vertical lines, by the way. If you did not know that.
I thought it was just one.
It's actually supposed to have 2. So when it's typed, sometimes it only has 1. But when we write it, I think we normally give it 2. All right, so let's check those 2 things. Inside the table, and guys, if you have colors, or really I'll say it like this, if you don't have colors to take notes in, get some, right? Because more and more we're going to be doing stuff like this, and we can't all share the same highlighters or stuff like that. It's just a little bit too difficult. So we're going to check inside the table first. I'm going to color that red. What is the multiplication to go from 1 to 20? times 20. Okay, what is the multiplication to go from 2 to 30?
Uh, 15.
Yeah, that's times 15. Uh-oh. That doesn't seem right.
Yeah.
And then this is times, I don't even know, but it's not 20 and it's not 15. So is the CP the same?
No.
No.
So when we ask ourselves question 1 of do we have the same CP? No, right? So this fails. That's an X like it fails. Sorry, I gotta scooch my notes. I can't drive today. What is going on? Then, when we check the outside multiplication, how do you go from 1 to 3?
30.
Times 3. How do you go from 20 to 40? Oh, that's...
I'm so.
No, you're good. I know why you said it. So the outside of the table also fails. Think about it like this. I hire Nate to come rake leaves at my house. Now, I don't know, but Nate, can I trust you to rake leaves?
Yeah.
No.
I
Okay.
read my leaves.
So he rakes leaves for an hour, and I pay him $20. I'm like, all right, Nate, go do the backyard. It'll probably take you 3 hours. And I pay him $40. Is that fair if I paid him $20 for the first hour and then... No, I cut down how much I pay per hour. If he raked leaves for 2 hours and I paid him $15 per hour, he'd be like, what? But I thought it was $20 per hour. This changes the rate. This is lame. Now, a babysitter or somebody might do something like this to entice people to hire them. Because think about it. If you're babysitting for somebody and they just need to like run to the grocery store, do some stuff, whatever, but you might be like, all right, $20 gets me over there and gets your first hour of me babysitting. If you need me to babysit for longer, like the parents want to go to dinner or something like that, and they're like, all right, we want you for 3 hours, you might only charge them $40 to give them a deal. You know what I mean? Because what should this be? If we kept the same constant of proportionality,
60.
60, right? This should be 60. So this table is not proportional. Not proportional. Not proportional. Questions on that? Try this one on your own. Whole numbers. You can just do age and height. You can just write down age and height in your notes. Turn to a neighbor. Obviously, don't like get closer to them, but have a little conversation about, do you think this table is proportional or is not? And defend it. You got to say why. So here's the thing about me teaching from up here. I can, but then it doesn't go in the video. So I can write on this board, but it won't go in the video, which is my only apprehension. So, chat. Yeah, chat with each other. Actually, I might as well just put it in my notes too. What do we think? Nate, what are you thinking?
I think it is proportional
Defend.
because
Let's check our CP together, right? What is this?
3 times 4
What is this?
times 5.
So wait, these are allowed to be different?
No.
So wait, I'm going to take you back to the first question. Do you think it's proportional?
Nope.
No. So these have different CPs. So you could just like off to the side write CP and put an extra like no, they don't match. So automatically we see that it's not proportional. Now Lacey, you also had your hand up. What else did you have to say?
Yeah, I was going to say that they didn't have the same CP, so they're not proportional.
Yeah. And if we look at the outside, this is kind of tough.
Yeah.
How do I go from 3 to 10? I'm not even really sure. It's times 3.
And 1/3?
Yeah, it's 3 1/3.
Yeah.
This is kind of tougher, so we wouldn't necessarily look outside. When the inside fails, we know it fails.
Yeah.
I think I got one more here. Oh, this one. I'm so glad I did not forget to do this. This one has a trick to it that I want you to listen to me first. This table has 5/6 and 2, 25/6 and 10, 125/6 and 50. Actually, go ahead and copy the table. I should let you copy it before we... This looks tough because they're all fractions. They're all division by 6. However, do you have a I saw you nodding. Lily, do you have a suggestion? Yeah, so we can essentially momentarily ignore the denominators. So, for a moment, I'm not saying that we can do this forever, but for a moment, ignore the division by 6 and just compare the denominator, the y value to the numerator. Since they all have the same denominators, we can ignore them for a minute. So since this is divided by 6, this is divided by 6, and this is divided by 6, ignore that for a second and just compare x to y, or y with x, or whatever you want to say. So if I compare 5 to 2, that's a times 2.5. Does times 2.5 work here? 10 times 2.5? Yeah, 10 times 2.5 gets you 25. Does 50 times 2.5 get you 125? Yes. So sorry, I'll scooch this over so you can see their table and my table. So if we ignore the division by 6 for a second, we can see that the constant of proportionality checks out. It is actually the same. We have times 2.5 times 2.5. Now I drew this in the wrong colors. Sorry, I drew this the other day. So that day I was doing my notes, the other colors around. So here the purple checks your constant of proportionality. Sorry that I switched colors. And then the outside of the table, times 5, times 5. Check the top, times 5, times 5. The outside also checks out. Both of these need to be true for it to be proportional. So this one passes, it is proportional. By the way, guys, before I forget, because I already forgot because I should have put it on the start slide, see all those cubbies over there? Next week, we're going to be wrapping up this unit. I'm also going to collect your math, whatever you're using. So if you're using a binder or a notebook or a stack of papers, that is not as good. But whatever you're using to keep your math notes that we take, that's going to turn into a mastery grade for quarter 3. So it's okay if you haven't been keeping track of them and they're kind of all over the place or whatever. If you have to tell me yeah, I need to fix that, it's okay. But what I'm hoping that you're at least able to hand me is a notebook that says Math 7, right? And has your name on it. So if you can't, you'll end up with a progressing on that. I think I'll be nice and do progressing, not missing. And a week later, you'll have another chance to show me your math notebook. And a week later, you'll have it. Now that we're back in school, like I kept saying on Zoom, since we're here and I can check your notes, I'm gonna check your notes. Natalie?
So I have one big binder that has a bunch of different sections. So
That's fine.
What would I do?
That's just hand it in. It's I'm not asking you to organize anything. I'm not asking you to do anything specific right now. I just want to see what you've been doing. So I have a mix of a binder and a notebook. If I was a student, I would just say I have a mix of a binder and a notebook here. But yeah, next week we're going to work on the unit test, probably here at school. We're going to work on the Khan Academy. Well, I might just make my own. I kind of like the idea of all of us doing it in Khan. Never mind, we'll talk about that later. I'm getting off on a tangent. So when they have that crazy division, just ignore it, assuming it's all the same. Now, I want you to read this for a moment, because now I'm going to speed up a little bit. I only got about 20 minutes left, and I'm hoping I can get through more stuff.
Wait, really?
Yeah, I know. Well, we didn't waste time like we do online. Online, taking attendance and waiting for people to show up and dealing with Zoom issues. We didn't waste any of that time. All right, so here's this situation. Sorry, I realize you guys are kind of far from the board, so I need to make things bigger.
Whoa.
Yes?
Can I explain what I think it is?
You've probably already seen this in practice, haven't you? So hold on, let everyone read it. Take a second to read it. If you haven't done this practice yet, you haven't seen it, but then we'll let Lacey explain. All right, Lacey, what do you think?
I say it is proportional
Why?
because you don't buy popcorn, so you don't ever add that extra amount.
We never buy the popcorn.
And from what we know, the price of the tickets doesn't change, so it's always $10.50. So for each ticket you buy, you spend $10.50. So that's
Absolutely.
the total price.
Please write this in your notes. This is what that situation would be because there's never any plus popcorn. They don't do that, right? They don't do the plus popcorn. So since there's never any plus popcorn, it is proportional. The price you pay, right? The price you pay total. So like when your parents take your family to the movies or whatever, they're thinking, how many tickets do we have to buy? What is it per ticket? And if you don't buy any extras, then it is a proportional relationship. If you buy, some,
Nerds.
yeah, I was trying to think of different movie theater candy, jujubes or whatever. Those are like break your teeth, super hard plastic. All right, try this one then. Anna does sit-ups to get ready for her first triathlon. When she starts, she does a sit-up every 2 seconds. But as she gets tired, each sit-up takes longer and longer to do. What do you think? Is this proportional? Yeah.
I don't think it is because it takes longer and longer.
That's the trick. It takes longer and longer each time. So yeah, Sydney's got it. It's like it's not proportional when things change, right? When things change as you go, it's not proportional. Very good. So now we get into solving proportions. Please draw a squiggly line across your notes because this is changing like our section of what we're doing.
Movie theater popcorn is always, movie theater food in general is always so expensive.
So if you can believe this, well, I'm sure you'll be able to believe this. So think about how much popcorn they make at a time, and think about at the end of the night, they probably have a lot of popcorn left over.
No, they have to throw it away.
Not necessarily. I had a friend in college who worked at AMC, and he would come home from work with trash bags full of popcorn.
Yeah.
Because a trash bag is clean when it comes out of the box, right? So like, if no one's thrown anything away yet, that's a clean bag. Fill it with popcorn, take it home. But we're talking big trash bags.
Yeah, my dad used to work at a movie theater, and that's what he would do. He would take home like trash bags of popcorn every night.
Yeah, can't say it's necessarily healthy, but
No, but free popcorn.
absolutely.
What if
All right,
it left over?
so
Don't want it to go to waste.
guys, I want us to be able to get off on tangents, but we have to be able to get back. I don't really love the number Q, so I'm going to put that as a question mark. Please make sure you have both of these proportions.
Yeah.
Oh, see, that's the other problem with me using the ink layers. I have to then remember to clear it.
I need a round paper.
Right by Sydney, and actually I'll probably make a couple locations so we don't have to. Anyone need more graph paper for your binder or anything?
Me.
I'll deliver a few sheets. If you don't have a binder and you need one, I probably have some spares. I might have to go get some out of storage. But yeah, ask us, right? We're here to help. So ask us for whatever you need.
I need an extra binder.
All right, so there are, you got to tell me at a different time. I will not remember what you just told me, but talk to me later, man.
Okay.
There are multiple ways to solve proportions, but there's one way that always works. And some of you have heard it called the butterfly method or cross multiplication. We'll get to that. But the first way that we're going to look at solving these is when the proportion is nice. And actually, I should put this in quotations, not parentheses. So if you want to write nice out here, this is a nice proportion because when I look across from 3 to 9, what do you notice? It's times 3. Hey guys, especially now that we're back in person, if I don't call on somebody, you can just talk. That's what I like so much better about not being on Zoom. You can just talk. So if I go times 3 across the bottom, I have to go times 3 across the top. Because they tell us this is a proportion. So what is K here then?
20.
What's 10 times 3, Nathan?
30.
30. I'm pretty certain that you just do those things to be silly, but I'm a little nervous.
No, I thought it was 2.
Solve the other one on your own. And this is where I really like having colors. Lily, do you need to be closer? Just stretching. You guys are good. Like, also, I hope we can get a bit more casual again with like you're not on Zoom and you don't have to worry about like whatever. Like if you want to get up and stretch, whatever. If you're in the back room and you want to get up and move, I don't care. If you want to go use the standing desk, I don't care. I miss my big counter from the back of the classroom. I wish I could have brought that over, but it only made it to the gym and they left it. So did you guys see the gym this morning on your little tour?
Yeah.
The one that's got all the, like Mr. Smith's gym, the whole other side of that is storage. So it's everything from in the school is just stacked on top of each other in there. What is this multiplication down here?
Times 2.
There's why I think you might have been thinking times 2. So 3 times 2
6.
is 6. Now, that works when the proportions are nice. But what about when they're not so? Oh, this one's for you. Sorry, one more nice one. Yes. Oh, I can just also show my notes here. That's the problem. There. So try that, or here, look at my notes. Try the new one, or go and wrap up this.
Is that Z?
Yeah, it's a Z.
It's so loud.
And I'm about to shut my door.
Somehow he's still going to do
See, but the door shuts quiet. You can't even slam these doors. Well, I guess that's kind of a slam. That's what I'd say. It's hard to be angry because everything's so nice and soft now. Like it's like a soft closed door. What's the multiplication we need to do here?
3 times 3.
Times 3 again, just like that first one. Oh, wait.
Yeah.
Wait. Darn. It's times 3, but that's going left to right.
So divided by
So if I go the other direction, we're going to divide by 3. Guys, please make sure this is in your notes. You might not have written it down thinking, oh, this one's easy. It's just like those other ones. We would have to divide by 3, giving us our z value of,
1.5. Wait, no.
nah, leave it as a fraction. Just leave it as a fraction. Leave it as 5/3. Does that make sense? That because we multiplied going left to right, we do the inverse operation and we divide going right to left.
Yep.
Now the other thing you can do to avoid having to switch your brain from multiplication to division is cross multiplication. So when we see situations like this, please go ahead and write both of these down, and then we'll talk about why these are a bit nastier than those first ones.
I don't know.
Nasty wasty, right? I think that's in the Grinch, right?
I think so.
I feel like it's been since before Christmas since I've seen you. Oh wait, it has been. I've seen you on Zoom, but nowhere else for real. If you think you remember how to cross multiply, go ahead and try it. So if we don't remember how to cross multiply, the first thing we might think about here is trying to do what we've just been doing. And I'm going to do this in pencil because I don't want any of this to be permanent. Going from 8 to 12 is not terrible. If you're really good at identifying these relationships, you'll notice 12 is an extra half of 8. So this would actually be times 1.5. But that's still kind of gross. I could do times 3 halves, but that's still kind of gross and hard to type into my calculator. So instead, when we check this, we say, it's not a whole number. Let's do a different route. So since this is not a whole number multiplication, I'm not saying it doesn't work, but it's not nice. So we're going to take an easier route, not easy, but easier, and we're going to say, okay, what is 7 times 12, and what is 8 times k, because those have to be equal. And if you're sitting here and you're like, wait a minute, what? Check it. If we think about a proportion being a fraction equal to a fraction.
Oh, I just wanted to say that 7 times 12 is even.
Ooh, yeah, we'll come right back to that.
Okay.
So if I think about one of the most basic proportions that we talk about, half of a pizza is the same as 2/4 of a pizza, right?
Yes.
If I cut a pizza in half, cut it in half again, and give you 2 of the slices, give me 2 of the slices, we each get half. This, in math, is what we call the cross products. So if you would like to write down cross products, that is the actual name here. Products because we're multiplying. So am I. I brought a banana, but I forgot to eat. Cross products will be equal, meaning 1 times 4 is equivalent to 2 times 2. And this is always true. So, you can write down cross multiplication if you want to, like, that's what most people call it. But for some people, that is kind of confusing, and they just want to see it, like really seeing it makes more sense. So, Lacey, you said 7 times 12.
Yeah. It is 84.
So that was what I had highlighted in yellow. Equals, we will write 8 times k. And guys, this goes back to your calculator doing the tough work for you. So cross multiplication is going to be what we call our step 1. I put a 1 right there beside cross multiplication. Then, if we have a variable to solve for, we then divide. Divide by what? The number we want to get rid of. So if you've never seen cross multiplication before, this may be new. I would advise you writing all of this down, please. So the number we want to get rid of here is 8. Because it's being multiplied, we use inverse operations, so we divide instead. We grab our calculator to do any math that's even remotely difficult. We just grab our calculator for now. 84 divided by 8. Oh, a little over 10 makes sense in my brain, right? We have at least 10 there. And what we get is actually 10.5. So guys, if you don't have your calculator in class with you today, please try to bring it for the next time that you're going to be here at school. Try this on your own. We're going to do the same process. We're going to cross multiply, so the diagonal pieces. we build the equation setting equal our two cross products. So what's one of our cross products here?
11 and 5.
Yeah, 11 and 5. So I'm going to go ahead and write the work out on this side. So we have 11 times 5 will equal 8 times n. So what we really have is 55 equals 8n. We want to divide. Now we won't always divide by 8. It just so happened that we had 2 in a row that divided by 8. And actually, guys, leave this as 55 over 8. Unless it asks you to make your answer as a decimal, we can say n is equal to 55 over 8. If it asks you to make it a decimal, it's 6.875. But because it goes 3 decimal places, it's pretty much easier to write it as the fraction. Questions on this process? Because you know I'm probably going to ask you to try it on your own. What, is your butt hurting from the desk?
Yeah.
Bring a pillow. I'm not joking if you want to. I know these desks are hard. Or bring your coat and like fold it up beneath you.
We can move a pillow.
I don't care. You guys are allowed to bring backpacks. So here, try. Yeah, try either of these. Let's do both of these, actually. Make sure that we're feeling comfortable. It's really a 2-step process that we can mainly do in our calculator, but we still like to write it down just so we have it written down. If you don't have a calculator right now, what you should at least be writing down is the fraction that we get to after the division. Does anyone want to be so bold as to volunteer to walk me through this? Like, tell me what to do and what to write down. Anyone not Lacey? Just 'cause I feel like I'm gonna have to pay her soon. I mean, it's okay. We can call on you. All right, Lacey, walk us through it.
Okay. So I started by multiplying 3 and 11.
I'm actually going to put that on this side.
Which gets me to 33. And so that is 4 times, that would be 4 times k, so it would be 33 over 4.
Yeah, so we get to 4k equals 33. We divide by 4. So if we don't have a calculator to solve it, k we could leave as 33 over 4. Even if we have a calculator to solve it, I don't think it's that nice. 8.25. Now, let's talk about the last thing we want to say, or the last new thing we want to say of how do we know. How could we check this? Please write this down. How could we check this? Anyone remember from previous classes? We can check it by plugging it in.
Oh, yeah.
So we rebuild the same proportion, except we plug in the value that we found. So what I mean by that is we set up 4/3 equal to 11 over 8.25, or if you wanted to write 33/4, you could. And then we check, are the cross products equal? 3 times 11 gets 33. Well, we already know that one, right? And then 4 times 8.25 gets us 33. So we set it up, and then we check, is it true? And it is. Because we can check the math, and we can find out it is true. for the last one here, if I was just trying to solve it using just a calculator, what would I do for this last one? Natalie, what do you think? What would I do for this last one? The 10/9 equals 3 over q. Can you tell me what I would punch into my calculator? You're good. I will skip past you. Martin or Isaiah, when you guys want to jump in? What do I have my calculator do? So this is why I'm asking, because I want to check if you guys like understand it yet, or if we need to keep practicing. So please write this down. 10/9 equals 3 over q. Hey, good morning.
Question for you.
Give me
I'm sorry.
30 seconds.
Yeah, I'm sorry to interrupt.
So this, we can do the cross multiplication, right? Those two numbers, we can do that in the calculator. Because we're trying to make the calculator do the tough math for us. Right, Mr. Allen? Why would we think when we can make the machine do it?
I'd rather think because it makes me a better person.
Ooh, I like that answer.
And I don't like to rely on technology when the apocalypse comes and there's no electricity.
The robots.
I'll survive and feast off of everyone else's corpses.
Just because you did the cross multiplication, right? So what we type in the calculator is that 9 times 3, and we're going to end up dividing by the 10 because it gets multiplied by q. Again, we could leave it as 27/10, or if we actually want to write it as a decimal, we'd get 2.7. Yeah, that's all we got the time for today, guys. So once you get that written down, go ahead and pack it on up.
What is the little thing you said to plug in? Did you say you figure out the little?
Yeah, it's Wi-Fi, I guess. That's what James, I didn't catch his last name, goes over here. My board came from Phoenix, right? So I don't have any idea where that is, if I ever had it. I don't think I did. Yeah, the little dongle thing. Yeah, you guys are heading to language arts. Sorry, we're out of time.
The little USB thing.
You mean your board from Phoenix?
Yeah, this is that board. Like that.
You got your
Yeah.
original one.
And I know that because I had that little post-it taped on it because people didn't know how to turn it on. So I still can't get Wi-Fi on my board because I don't have one of those little USB doodads.
So that is something that we never have had in any of the other models we've received. So, and these are all, only thing where these have gotten was these weren't supposed to have like network. That's why we bought them that way. They're cheaper.
Yeah.
And all the network doesn't go through the computer.
Right.
So
now wherever those USBs came from, they're giving the boards access to the network because I've got other people's
but it's
boards
got to communicate
connected.
with something.
It's the little USB thing is letting it hook up to the Wi-Fi.
So it's connect. That's
Yeah.
allowing.
So not mine, but if you walk over like Amanda or Terry's, I
I've
got
seen
their
them
set
all. I
up
just
for
didn't
'em.
know. I mean, I'm just trying to figure out how it all works. I mean, it's communicating with our access points. Is that what you're thinking?
Yeah, it literally just once you plug in that USB and turn the Wi-Fi on. So I can show it to you on my board, but it won't turn on. So actually, let me stop my recording.
Should we wipe off our desks?
It must be the new one. Must be a different model that comes with that.
I'm still recording my class, so hold on.
Mr.
It
Ryan,
says
should
if
we
you plug
wipe
that
off our
into this.
desks?
Oh yeah, I'll do it.
okay.
I'll have the other class do it. Thank you guys for thinking about it.
So it allows the flat panel to connect directly to Wi-Fi. So that's what
Yeah,
that
that
is.
makes sense. I mean, that part makes sense. But
I have way
Now,
too
I
when
didn't
you
know
got
that.
this, it didn't come with a monitor remote, did it? Either.
No, it came with a Bluetooth remote that I have taped up there, or the like speaker remote.
Yeah. So he didn't have a monitor.
the speaker bar, yeah. So yeah, so you need one and you need one. You're the only two that so far can use.
And we might want to
Because we're the only two that have the old ones from the other building.
Okay.
Because you ended up with Kevin somehow.
Yes.
Yeah, because when I checked before I left to bring one, and they said that we didn't have any at the time, or when I left.
Right.
But I don't know if we might still be able to get some more. And I'll tell them, I'll explain why you guys don't have.
Hey,
it.
we need to wipe down our desks, so grab a wipe. I forgot in the last class,
Right,
guys.
so we don't have the monitor remote or the little. What do you know what those things are called?
Just say it's a wireless USB. But I'll follow
See,
up.
dongle's confusing people though, because they're thinking we're talking about the video adapter.
Right.
So when I went and asked Sean for a dongle, that's what he brought me back. Sorry, guys, I'm trying to get to getting rid of. So the settings thing of where you go to turn on is just in here, and then network. And if you have one of those dongle things, it'll let you turn on Wi-Fi, but it won't let me because I don't have one of those. So every time I do that, it just says no, just kicks it back. So I need to play that menu and go back. Sorry, I gotta figure out how to get my recording stopped from earlier. This would be the funniest end of class. It's just like people just talking. No problem.
All right.
All right, plan book, graph, paper, pencil, sit. where you would like, that does not mean the back of the classroom, so we're going to fill the front rows, but if you want to sit closer to the window, sit closer to the window. If you don't want to sit close to the window, that's up to you.
I'm gonna recommend you guys sit up front though.
Yeah, we're not like sitting in the back of the room, we're sitting in the front of the room.
The guy over at the other school that I share my stuff with.
I literally can't, I've like lost my little recording thing. It's disappeared.
Can I go to the restroom?
Yes, yeah. Guys, if you need to go to the restroom,
Yep. That's good, like the same.
this is embarrassing.